welcome to the 16th video of lesson number 4, Ratio and Proportion of Mathematics Part 1 of Standard 9. In previous video, we have started and solved some questions of practice 4.4. Now in this video, we will solve the remaining two questions, sub-questions of question number 3. Let's see the first sub-question which we have not yet solved, that is, see if A in bracket x plus 1 y plus z is equal to B in bracket z plus x is equal to C in bracket x plus y. So this is a monomial into binomial everywhere, and out of ABC no two terms are equal, then show that this we have to show these three ratios to be equal. Okay, now when we want to show such ratios equal and what is given to us, let's start with the given thing. So let me copy over here. Question 3, sub question 1. A in bracket y plus z is equal to B in bracket z plus x is equal to C in bracket x plus y. So this three products are equal. This is given. Okay. Now here we do not have any ratio. Okay. So generally when we have ratio, say A upon B is equal to C upon D or is equal to E upon F, and then start using certain operations or theorems on equal ratio, we can prove certain ratios are equal. But as here we do not have any ratio, to get the ratio from this statement, we want something in the denominator. Okay, if you observe here the monomials A, B and C, and here in the denominator if you observe, so numerator we have x, y, z, and in the numerator we do not have anywhere ABC, but here we have ABC, and in the denominator here we have ABC, whatever may be the term in order. So numerator we want x, y, z, denominator we want ABC. So if we want to remove this ABC from the numerator, we can divide all these terms by ABC. Okay, so let's divide by ABC to each term. Then what we will get? So it's A in bracket y plus z upon ABC. Why we are dividing by ABC? Because here we have A. To cancel this A, we want to divide by A. To cancel this B, we have to divide by B. And to cancel this C, we have to divide by C. That's why we have to divide each term by ABC. Okay, is equal to B in bracket Z plus X upon ABC is equal to C in bracket X plus Y upon ABC. So as we have thought that we will divide this A at here A. So this A has gone from the numerator. Here this B has gone and here that C has gone. That's why we have got this ratio that Y plus Z upon BC is equal to Z plus X upon AC is equal to X plus Y upon AB. So we have got this ratio. So from this given three statements where we do not have anything in the denominator, or let's say it was 1 in the denominator, we have got this in the denominator, and we have removed this ABC from the numerator as well. Now what we want, how can we get this y minus z upon, what is this, y, the first ratio is y minus z upon A in bracket B minus C. So if we simplify this bracket here, it is y minus z upon its AB minus its AC. Okay. Now here everywhere we have addition, we do not have subtraction. But in the denominator AB, do we have AB? Yes, we have AB. AB is our third denominator of the third ratio. And where is your AC? AC is the denominator of the second ratio. If we want AB minus AC, okay, so if we take first this ratio, we are doing the rougher part, that if we are taking say x plus y and upon AB, okay, from this if we want to subtract AC, AB minus AC, where is AC? AC is this second ratio. If we want to subtract this, then we have to subtract this z plus x from this. Okay, so we are doing subtraction of this third term and then the second term. What we will get? We will get this whatever we want it here in the denominator as AB minus AC, and here in the numerator x plus y minus z minus x. Simplify, minus x plus x will get cancelled. So we are getting y minus z, which is actually being made over here. So to get the first ratio, this y minus z upon a in bracket b minus c, what we have to do? We have to do the subtraction. Similarly, we can get the rest ratios also. So let's write whatever we have got. This we can say all these ratios, let it be k. Okay. Let's write let y plus z upon we can use directly theorem on this. We have already these three ratios. We do not want to show each ratio is equal to some number. So all these three ratios are equal. Okay. So by theorem on equal ratios. Okay. So this k is equal to that we are going to have this AB minus AC, means we are going to have this AB minus AC for the first, the required term here, okay, is equal to AB. What is the numerator of this third term? It is x plus y, and minus it is z plus x. So we are subtracting by taking this ratio first, and from this we are subtracting this. Let's simplify here. X plus y minus z minus x upon, here take a common, b minus c, and then this gets cancelled. So here we get y minus z upon in bracket a in bracket b minus c. So we can take it as statement number 2. Let's take this only statement number 1. Okay. So by theorem on equal ratios, say whatever that each, this we are going to take it as k. Okay. And then another similarly, so value of this ratio is k. Again that k is equal to, now here let's see what is the second we want here. This. So we have got this first thing, that y minus z upon a in bracket b minus c. Now to get this, now what is the product of BC? That is b into c is BC, which is the first term, and then it is BA. So here we want BC minus BA. BA means nothing but it's AB. BC minus BA, that is AB. So BC is the first ratio, its denominator. So let's write here y plus z minus AB is the third, where we have to write x plus y. Simplify this brackets in the numerator, y plus z minus x minus y. So here y will get cancelled, and here taking b common, you will get it c minus a. B common, c minus a. And of course we have here it's z minus x upon b in bracket c minus a. So let's take this as statement number 2. So whatever these ratios we have taken, whatever subtraction addition we are doing, it's equals to k, its first ratio. This k is equal to the second ratio. And now let's take the third one here. Similarly, k is equal to, now here in the third ratio we want CA, that is AC, minus CB, that is BC. So CA means it's AC minus CB means BC. So it's BC. So we are taking the second ratio, its denominator, and we are subtracting denominator of the first ratio. So we have to take the numerator here. Okay. What is above AC? It is Z plus X. Take it into bracket minus what is above BC. It is Y plus Z. Okay. So now simplify this, Z plus X minus Y minus Z upon taking C common, it's A minus B. Here minus Z plus Z will get cancelled. So we will get x minus y upon c in bracket a minus b. So let's say statement number 3. Now the required three ratios which we have to show it equal. So from statement number 1, this ratio equals to k, this ratio is equals to k, and this third ratio is equals to k. So we can continue here. So from 1, 2 and 3, all these three ratios are equal. They are all equal to k. So you can write this y minus z upon a in bracket b minus c, that equals to z minus x upon b in bracket c minus a is equal to x minus y upon c in bracket a minus b is proved. Okay. So what we have done here, let's have a recall quickly. Basically here we have been given this statement. From this statement, to get ratio, we divided each term by ABC, so that ABC in the numerator has been cancelled, which we do not want it here, and we have got this ratio. Okay. Now you can say if you want as the previous sums, you can say here let all these sums equals to k. You can write this, and then by theorem on equal ratio, k is going to be equal to. Here only we have to see what operation and which ratios we have to do. For that we just observe it here that in the denominator is AB and minus AC. That's why we took this first ratio as this AB, and then minus we have taken this AC. AC is here. So we took the third ratio and the second ratio. Accordingly we have taken subtraction and we have got the required thing. Similarly for the next terms also we have seen what we want from which ratio terms of the ratio we have to subtract the terms of the which ratio. Accordingly we just observed, decided, and we have got that we got k is equal to first ratio, k is equal to second, k is equal to third ratio. As all these are k, it is all three ratios are equal, hence it is proved. Okay. Now let's go for the fifth sum. How to solve? Let's see. Now in the fourth sub question, not fifth, in the third question, fourth one it is, if y plus z is equal to a, if is equal to z plus x upon b is equal to x plus y upon c, then we have to show that x upon something, y upon something in ABC, and z upon something in ABC, these three ratios are equal. Now when you want to show these three ratios are equal, okay, and the three different ratios are given to be equal, you have to observe that which variables are used in the numerator and denominator. So here we can see x, y, z are the numerators, and here also we have x, y, z. So no problem. And ABC is in the denominator. Here also we have ABC in the denominator. If something is not like this, suppose we have x, y, z here in the numerator and here in the denominator, then we can write first whatever given ratio, and then we can take its inverted. But here it's not required, so we can keep it as it is. So we will start this answer here that whatever three ratios are given, say y plus z upon a is equal to z plus x upon b is equal to x plus y upon c is equal to k. So let's write all three ratios are equal. Okay, and now using this by theorem on equal ratios, in theorem on equal ratios, either we can add or subtract, or whatever we have to multiply and then add or subtract the terms in the numerator as well as terms in the denominator. Now what we have to do, here I would like to give you one smart tip, one simple clue that how we have to observe. See, from here it is y plus z, from that how to get y, it's a little bit difficult, or you can say here we can do, we can go from, instead of here this is one term and here we have more than one term in the numerator. But if you observe here, to prove it, here there are many terms and here you have only one term. Go from one term to many term. This is my clue. Go from one term to many term. So here whatever we have written that equals to k, one term is in the denominator, and to prove many term, here it is in the denominator. So concentrate on the denominator. For the first term, what you want here b plus c minus a. Means what you can do here by theorem on equal ratios, if I write say k is equal to, how can I get b? So first write the denominator b. B means what? It's the middle term. If I am writing b term in the denominator, I should write z plus x in the numerator. If I want here plus c, so this binomial, c is the denominator of the third ratio. If I am adding c here, I should add the numerator part here, x plus y, okay, and then minus a. I am subtracting this denominator of the first ratio from here, so I need to subtract this numerator also, y plus z, okay. So that's why we can write it further. Therefore k is equal to, let's do this simplification, that z plus x plus y minus z upon its b plus c minus a. B plus c minus a. Now get simplified. Minus y plus y will get cancelled. Minus z plus z will get cancelled. So it is 2x. X plus x, that is 2x upon b plus c minus a. Okay. So actually here we have got the required denominator b plus c minus a. But instead of x, we have got here 2x. Let's see if we get similar terms here. Instead of y, if we get 2y, and instead of z, if we get 2z, so we can remove that 2 from the numerator. Let's say this is statement number 1. Okay. Now similarly, now what we want for the second term? Second term we want y upon c plus a minus b. So similarly I can write here k is equal to, so what do we want? C. C is the third term, denominator of the third term. So let's write its numerator in bracket, that is x plus y plus a plus a. A is where it's the first term. So its denominator is added here. So add the numerator y plus z. Y plus z minus b. B is the middle ratio. Its numerator is z plus x. So this is the third ratio, x plus y upon c. Okay, we have done this first. Then plus we have added the first, y plus z upon a, y plus a upon a. So we have added this first ratio and subtracted the middle ratio, z plus x upon b, z plus x upon b. So this both the terms we have subtracted. Okay, is equal to, now let's simplify it, x plus y plus z minus z minus x. As it is minus, these two terms will change their signs. Both will become minus. New denominator is as it is c plus a minus b. Now plus z minus z plus x minus x will get cancelled. Y plus y, it's 2y upon c plus a minus b. This is statement number 2. So here also, instead of only y over here, we have got it 2y. So let's go for this term. How can we get the third term? So here similarly means we are using again theorem of equal ratios. So k is equal to, now here we want a plus b minus c. Okay, so a plus b minus c. So a means what? A means here it is the first term. What is the numerator of that? Y plus z. That we will write plus b. B is the middle term. Its numerator is z plus x. And then c is the last term. Its numerator we have to subtract, and c is minus x plus y. Simplify. So simplifying the numerator, y plus z plus x minus y. This is becoming minus upon a plus b minus c. Plus x plus y minus y, z plus z, it is 2z upon a plus b minus c. This is the third term. Okay, so by using theorem on equal ratio, we have got that k is equal to 2x upon this, k is equal to this 2y upon this, and k is equal to 2z upon this. So from first, second and third statement, we can write all these three terms are equal. We are going to collect these three terms, what we have got in this three statements. Okay, so we are going to write it as 2x upon b plus c minus a. It's 2y upon c plus a minus b is equal to 2z upon a plus b minus c. So all these three terms are equal because all are equals to k. Here everything we have started with k, correct? So all this is equals to k, and this is middle k. Okay. So now only what we want, we do not want this 2. So let's divide by 2 to each term, okay, to each ratio. By dividing by 2 to each ratio, we can get that required thing, that x upon b plus c minus a is equal to y upon c plus a minus b is equal to z upon a plus b minus c is proved. Okay, all these three ratios are equal, is proved. So hence we have proved this required three ratios to be equal in this way. Okay, so here while simplifying such sums where the three ratios are even equal and we need to show three separate ratios to be equal, what we have to do, you have to use the smart trick that go from 1 to many. So in the given, concentrate where only one term is there and go for the many. Okay, so even this previous sum also we had gone from one term to many. Okay, so AB, AC. So in the after dividing by this ABC, whatever we have got, then also we have used the same technique, and here also we have used the same technique. So by using this technique, you can solve sums like this easily. I hope you have understood these two sums, how to solve. You have to do little bit practice of such sums. So you can certainly do that. And if you find any specifically any sums to be solved, you can give me in comment box. I can make video on that to solve that required sum by you and upload it on the YouTube. Thank you very much for watching this video. If you are not yet subscribed to the channel, please subscribe and do not forget to press the bell icon. Thank you very much. Okay, once again, keep watching.